All right, guys, so here is the third proof that you guys did. So just to kind of pre-plan, it looks to me, so AD, these two are equal. 3 and 4 are equal, so we're not talking about the angles in the triangle, but we want to get 1 and 2. I think that's probably going to be a way to get 1 and 2 to be congruent. And we know DB bisects ABC. So ABC is over here, so we're talking now about this angle and this angle. So let's start there. So one of the givens is that, I'm sorry, that is what we're trying to prove. So we don't actually know that happened yet. All right? Now, this is going to be actually an introduction to what we are already going to learn for the next thing, which is CPCTC. So basically what I want us to do right now is we're trying to get these two triangles to be congruent. Because if these two triangles are congruent, that means that automatically these angles have to be congruent because they're part of congruent triangles. But we don't know that yet. So let's first try to get these two triangles congruent. Well, right away I can see that they share line BD. So BD is congruent to BD. That, and you didn't have to put this as line number 1, but you would have had this in your proof somewhere. The reflexive property. Okay. Now line number 2. Let's go just with the other given. AD is congruent to CD. That's a given. Okay, that's one of our sides, neither of which needs to be cited in any way. So now let's get into line 3. Line 3, so we know that angle 3 is congruent to angle 4, but those are not part of our triangles. So what we want to try to do is say things about angle 3 and angle 4 that might include 1 and 2. So like one thing I can say, and that's what you're trying to always do, try to get like angle 1 in your proof in some way. Well, I know that 1 and 3 form a straight line. So I can say angle 1, and it'd be the measure of angle 1, plus the measure of angle 3 is equal to 180. And that is because of, we learned that was the name of the linear pair property. Line 5, I could say the same thing about 4 and 2. So angle 4 plus angle 2 is equal to 180. That also is because of the linear pair property. Now, I want to try to get so that angle 1 and angle 2 are equal to each other. So that means I need to write equations where they're on both sides of the equal sign. Well, here's angle 2 and here's angle 1. So how can I get them into an equation where they're both on opposite sides? Well, right here, this one equals 180, and this one equals 180. So couldn't I just move this one over here? And that's what I'm going to do. I'm going to say that I know because of lines 4 and 5 that angle 1 plus angle 3, and remember, I'm doing a bad example here. I'm not putting the measure of, but it should be measure. And angle 4, measure of angle 4, plus the measure of angle 5. Just a little hard to write on this screen. And that's the substitution property. Or in a way, that's the transitive property. If I would have said 1 plus 3 equals 180, and if I would have changed this to then 180 equals something else, I could have put them back to the beginning, and that would have been the transitive property, but we're just going to use substitution. And that's based on lines 4 and 5. Don't forget to cite. Well, 1 plus 3 equals 4 plus 5. We do know, back in line 3, that 3 and 4 are exactly the same. So I'm going to write this, instead of 3 and 4, I'm just going to write this as line 3. And I'm going to change the 4 to a 3, because we can do that because 4 and 3 are the same thing. And there's a reason why I'm doing that. If I put a 3 on both sides, then I could subtract them. So this is, I'm substituting based on line number 3 and line number 6. I'm substituting the information line 3 into line 6. Well, now, because I have angle 3 on both sides, I can just say that the measure of angle 1 is equal to the measure of angle 5. Because all I did was I subtracted 3 from both sides. So that's the subtraction property of equality, POE. Now, I have enough information to say that my two triangles are congruent. And that would be because of side, angle, side. So now my triangles are congruent. And you have to say that they're congruent, and you're going to list side angle side. Remember, you would have cited three things here. Well, once you have congruent triangles, now that I know they're congruent, I'm allowed to say, because it's true, that angle ABD is the same as DBC. And just for you guys, just for this purpose, I'm just going to call it angle, I can't call it 3 and 4, I'll call it angle 6 and angle 7. So I'm now going to say angle 6 is congruent to angle 7. And the reason why angle 6 is congruent to angle 7 is that's CPCTC. This means corresponding parts of congruent triangles are congruent. It means that once you prove congruent triangles, every side and every angle is going to be congruent in them. And then line 11 is basically what I was trying to prove, that I forgot what it said in the proof, but something bisects the angle. And the reason why I know something bisects the angle is because of line number 10. Line number 10, I'm using the fact that 6 and 7 are equal, that's the definition of a bisector. And for CPCTC, I'm going to have to cite number 9 because it's based on these congruent angles.